Hey everybody, this is Mr. Beckstrom, and today we're going to look at section 6.3, and it says simplify the expression by using appropriate identities. Do not use a calculator. So we have the sine of 11 degrees times the cosine of 50 degrees plus the cosine of 11 degrees times the cosine of 40 degrees. So this is pretty close to either the sum of the cosines or the sum of the sines identities that we've learned about, but it's not quite there. Notice that this is the sine of an angle times the cosine of an angle plus the cosine of an angle, but if this was the sine of an angle, we would be there. And let me copy that over. This is from hold on, just this from page 513. So if we actually assigned the 11 degrees our angle A here, and the 50 degrees our angle B, as you can see, this would be the sine of A, the cosine of B, plus the cosine of A. And here we have the cosine of 40 degrees. So notice that that doesn't fit. We have the sine of B here. So how do we make this cosine of 40 degrees into the sine of 50 degrees? So we need the cosine of 40 degrees, right? We need that to equal to the sine of 50 degrees in order to make this formula here work. So that's our dilemma here. This is how we make this formula work. All right. Well, we do have a cofunction identity from this same section here. And so if we look over at those, we have, I'm going to copy this over here. We have this one right here, and this is the one that we're going to be using. And this says that the cosine of some angle is equal to the sine of, and we can use either radians or degrees. They gave it to us radians, but the equivalent degree for pi over 2 is 90 degrees. So let's try to use that one here and see if this will work for us. So this says that if we put cosine of 40 degrees, that's going to be equal to the sine of, remember pi over 2 is just 90 degrees if we're in degrees, minus our original angle, which was 40 degrees, which is equal to the sine of 90 minus 40, which is 50 degrees. And look, using this cofunction identity right here, we got the cosine of 40 degrees to turn into the sine of 50 degrees, which is exactly what we wanted. So now, this is exactly in the form of this right here. Let me make that a little bit bigger so hopefully you can see that. So really, we can reduce this entire thing now down to, and I'm going to go ahead and just put like a line through this, because we know that the cosine of 40 degrees is equal to the sine of 50 degrees. 50 degrees, and this is just that angle there is going to be our B. And this thing can now be simplified or written as what? The sine of A plus B. So this can be written as the sine of 11 degrees plus 50 degrees, which is equal to the sine of 61 degrees. 61 degrees. And let's go ahead and check this in our calculator. Okay, so go to mode, make sure I'm in degrees, which I am, and I'm going to put the original thing in here. So that's the sine of 11 times the cosine of 50. Cosine of 50 plus the cosine of 11 plus the cosine of 11 times the cosine of 40 times the cosine of 40 and I put that in there, and I get this decimal approximation. So if I'm right, that should equal just the sine of 61 degrees. Sine of 61 degrees. So if we're right, that should be the same decimal approximation as that, which it is. So we are good to go. That's an easy way to check our answer. All right, I hope this helped. If you have any questions, let me know, and hope you have a great rest of your week. Thanks.